All right, we are back, and again, we've still got a gain of 1. Our process variables on the left meter, that's our measurement from our level transmitter coming in. It's saying that we've got 50% 12 milliamp signal, which means we got 15 inches of water in that tank, and that tank's calibration range is from 6 to 24 inches of water, and 15 inches of water in there is going to be 50% of the level, okay? Now, since we have no error, there's no difference between set point and process variable, then our output sits at 50%. Remember that formula, V sub O is equal to P sub G times the error plus 50%. There's no error to add to the 50%, so we're sitting at a 50% output. Now, when you look at this, you can see it's at 12.01, and like I said earlier, this is my knock-around meter, my own personal one, and it's probably off by 1/100th of a milliamp, okay? So we're not going to split hairs here. Let's go back to the Crimson software here, and let me see if I can get this to focus on here. And what I was telling you earlier is that this setting here for proportional band is to say how much is it going to take full scale to make a full scale output change. So what we said here is it was going to take 18 inches of level change on the input to make a full scale 18-inch 100% change in output, essentially, right? So now we're going to change our proportional band to 50%, saying that I only want to make a 50% change on input. I want to see a 100% change on output, which ends up being a gain of 2. So we're going to change this to 9, which is half of our span. So we're saying now it's only going to take half of our span to make a full scale change in output. Now the other thing that we got to do with this software is we actually have to send this thing down there. So we come into link and go to send, and it's going to send that new proportional band setting down to the controller. So we're going to come over to the controller, and it's still sitting here. Nothing's changed because we don't have any error. As soon as we have error now, we would anticipate that we're going to get twice as much change in output. So I'm going to go up by 10%. I'm going to go up to 13.6. And what we would expect to see on the output is a 20% change, okay? Well, 20% of 4 to 20 milliamp would be 1.6 plus 1.6 would be 3.2. So from 12 milliamps, we should have came down to 8.8, okay? Again, we're off a little bit. Don't split hairs here, all right? At the end of the day, we had a 10% change in input. We had a gain of 2, or proportional band of 50%, and our output changed by 20%. So again, we just proved the formula. V sub O is equal to P sub G. Well, the gain is 2 times the error, which was 10%. So 2 times 10 is 20%. Plus the 50. Well, we're going reverse acting, so we subtract the 20% from 50, and we end up at 30% of a 4 to 20, or 8.8 milliamps. So that is how that works in this setting. So we're going to go ahead. We could do more multipliers, larger errors, but at the end of the day, it all works the same. What we're going to do is end this video right now, and then the next video, I'm going to introduce integral, and I'm going to show you how integral will affect the output over time.